Morning, Evan Shaw here from AMT Composites. Today we're just going to take you through some of the procedures that are necessary when you're working with these epoxy resins. Obviously scales are very, very important. So we provide a nice little 5 kilogram scale. We also have a smaller 2 kilogram scale if you need. Today I'm going to be using the 5 kilogram scale. It weighs at 0.1 gram increments. So it's nice and accurate. I'm going to be using Crystal 30 resin and hardener. Obviously, when you're working with epoxies, what is critical and very important is that you wear proper safety equipment, so gloves, definitely. Protect yourself at all times. Try not to get these epoxies on your hands. Nitrile gloves are the better option because they are more chemically resistant than latex. So stick to nitriles wherever you can. As I said, today we're going to be using Crystal 30 just to demonstrate the mixing process. One of the things that you'll always get with the resin when you buy it, or you can download it from the web page, are the data sheets. Now, the Crystal series has a whole range of different epoxies. There's a 6, 10, 82, 30, 50, 55 and 100. The difference between all of these is basically the maximum casting depth. So on the Crystal 6, 5 mil, on the 10 it's 10 mil, on the 82 it's 10 mil, on the 30 up to 20 mils, on the 50 up to 30 mil, 55, 35 and 160 millimeters. So today, as I said, we're going to be using the Crystal 30, and the Crystal 30's mix ratio is 100 to 33, and it's mix ratio by weight. On the bottle, we also put the mix ratio by weight, and that PBW stands for parts by weight. We highly recommend using weight and not to use volumetric measurements, because temperature has a huge effect on the specific gravity and the volume of the different products. So it's always advisable to weigh it, because when it's cold, things shrink. When it's hot, things expand. And obviously, it doesn't affect the weight, it only affects the volume. So that's why we always recommend using weight. Put your container on the scale, hit the tare button, make sure it's 0. You can calculate how much you need, but I'm just going to take an arbitrary figure of around about 200 grams, just to show you. So there I've gone a little bit over. So I've gone to 212 grams. I need to calculate the volumetric equivalent, the hardener requirement. So I'm just going to go to my phone, get my calculator. I've got 212.5, 212.5, and I multiply that by 33%. And equals, I need to add 70 grams to this. Now there's two ways of doing it. One, I can hit tare, go back to 0, and then just put in the hardener at 70 grams. Or I can leave that where it is and just add this 70 grams to that 112 just by going plus equals on my calculator. And that equals 282.63. So now I've got to be careful that I don't go over. And I must put this in until it says 282. And I've got to watch those numbers very, very carefully. 250, 60, 70, and yeah, I've got to slow down. $282.6. I'm on 282.6. Right. It's always a good idea to, once you've finished decanting from the one bottle, you put the lid on so that you don't cross mix your lids. When you're finished with the next one, you put the lid back on there. So if you accidentally bump it over, you're not going to mess your epoxy all over the show. So here we've got the two components in the bucket, mixed nicely, or measured out nicely. The next thing is mixing. Always choose a stick with a flat tip. There are options to do shear mixing if you ever want to do shear mixing on a drill, but we still recommend using a stick even after shear mixing, because the shear mixing will only mix the middle of the container. It will not mix anything that is on the sides or on the bottom of the container. So having a flat paddle stick like this is important. And here you can see we're mixing it. And then scrape the side of the container, turning the container, scrape the bottom of the container, stir, scrape the sides and the bottom of the container. And we do this for about 2 to 3 minutes minimum, longer if you're not sure, but not less than 2 to 3 minutes, to make sure that it is absolutely 100% mixed. Scraping the sides, very important. That takes the epoxy that you poured in first off the sides and out of that bottom corner, and that's why we use a square bottom stick, so it can get into the bottom corner. And obviously, as you're stirring this, you're obviously going to be introducing a lot of air into your mixture, and we'll demonstrate to you how we degas this before pouring it, so that you get very few bubbles. Also, temperature makes a big difference. The colder it is, you need to warm your resin up. And one of the important things to remember is, if your ambient room temperature is warmer than 25 degrees, you must reduce your maximum casting by 50%. So if Crystal 30 says that you can go up to 10 mils in one go, but you're working on a very hot day and the temperature is above 25 degrees, it's highly recommended that you reduce that casting depth by 50%, so only cast up to 5 millimeters in one go. An exothermic reaction happens when you mix these two chemicals together. There's a chemical reaction that takes place inside this container, and these little molecules start to bump into each other and to what we call cross-linking. And when they cross-link, if they are kept in a container, that's why we also talk about pot life, where you'll see pot life here is 40 minutes. So I've got 40 minutes to get it mixed and stir it and what have you. But if I leave it in here in this mass concentration, it can start generating a lot of heat, and that heat is what we call the exothermic reaction. It causes a faster chemical reaction, and then it just gets run away and eventually starts to get extremely hot in the container. So it's very important to keep note of the times, the mixing times, and then obviously once you've poured it into your job, then it's a 24-hour cure time for Crystal 30. So it'll take 24 hours to fully cure. In the colder temperatures, that time will be extended. It'll go up to even double in some instances if it gets very, very cold. Right, so the important thing is when you're mixing is to make sure that you need to leave this to cure between 18 and 23 degrees. Don't let it cure in a very, very hot or very cold environment. You need to keep that environment at around 18 to 23. So work in an environment where you've got an air conditioner, if possible. If not, choose a warmer day. Don't choose very, very cold days. And also, if you're doing any pours late in the afternoon, especially in the winter time, it starts to get cold from about 4 o'clock onwards. So you need to make sure that you do this early in the morning so that the bulk of the cure, the first initial part of the cure, is in this warmest part of the day possible. Everything is on the data sheet. Very, very important also. If you're doing a mass pour, you're doing a big table, a very deep table, it is important that you keep the concentration that you're pouring low. So if it's a very big table, reduce your maximum casting thickness by 30 to 50%. So as to avoid anything like shrinkage, distortion, cracking, because of the exothermic reaction. So you need to also think about how if you're casting a large amount, more than 5 or 10 kilos at a time, to consider reducing your casting thickness by 30 to 50%. If it's a small table, a little coffee table, breadboards and things like that, you don't have to worry about that too much because your mass is not it's not huge. So when you're talking small amounts, don't really worry about it, but anything over 5 to 10 kilos, consider reducing your casting thickness. So the next thing we're going to show you is how we degas this product. We're going to put it into a vacuum degas chamber. We'll set up for that and we'll show you how we do that in a minute.